Moving on, we are halfway on the metrics. So talking about the conductivity or electrical conductivity is basically the ability to allow the flow of electric charges. Normally, water or pure water is highly insulating, so it doesn't allow for electricity to pass through. But as soon as we have dissolved salts, then we have a little more conductivity. So that's why conductivity or electrical conductivity, along with temperature, is used to calculate salinity. And this is, of course, important in seawater, but also the amount of dissolved solids. And of course, we cannot differentiate what type of solids we are measuring. So we call TDS, or total dissolved solids, as we cannot determine whether the substance that is dissolved in the water is salt or something else. In the case of seawater, of course, it's important, the electrical conductivity, to estimate the salinity. It's important for understanding the concept of buoyancy or floatability, for instance, to understand where boats or ships can navigate through, and also the types of organisms that can develop in water. It is also important for the formation of currents because this dissolved oxygen, the dissolved solids affect the density of the water, and this is directly related to how much or how the water masses can flow and go and move within the ocean. Finally, they also have an impact on the CO2 absorption of the ocean. So the higher the salt concentration, the lower the CO2 absorption capacity of the ocean is. How do we measure conductivity? So we will use probes. In this case, you will see that probes have different ranges, and most of you have requested what we call the K10 or the K1 range, which is a very fairly normal range for freshwater or seawater as well. These probes, if you want to calculate salinity, you will need to take measurements of temperature along with the conductivity. And normally all of you have also included a temperature probe, and it gives a lot of metrics. So it doesn't only give electrical conductivity, but also, as we were mentioning earlier, it's also giving dissolved solids, salinity, and what we call a specific gravity. This probe, luckily, and contrary to the dissolved oxygen probe, is very easy to prepare. It's a little tricky, not too much to calibrate, and very easy to maintain. And as a general rule, take the sample and just measure it. But if not, you can take it to the laboratory and simply mix the sample again, or just simply leave the sensor taking continuous readings on site. Moving on, almost done for the metrics. Oxidation reduction, or ORP, is basically very related to pH. And so with pH, we were measuring hydrogen ions, and now we are measuring electron activity. So it represents how strongly electrons can be transferred, but it doesn't represent how many electrons do we have. And this can indicate whether the water has elevated levels of contaminants. For instance, nitrates or arsenic or other man-made contaminants, which are, for instance, heavy metals or others, can be determined by the ORP levels of water. The probe looks very similar to the pH one. It only changes in the color and, of course, the composition. It's very delicate. Well, it also has a glass bubble. Normally has a range in millivolts from negative to positive, somewhere from the -1 volt to the +1 volt electron concentration. And nothing particular to say about this one, other than a similar kind of considerations with respect to the one of pH. And finally, temperature. So the last one you have is a temperature measure. It's very important because it affects almost everything, the dissolved oxygen, the pH, conductivity, and salinity. It also affects how fast the chemical reactions occur. And of course, it can affect the type of life that can develop in water. And finally, it also affects density indirectly by salinity and on other factors. So in large masses, it can show enormous variations and then provoke currents within the ocean itself or the masses of water. It is very important in terms ecologically, and normally, since it's related to the chemical reactions, it means that the higher the temperature, normally the higher the biological activity. And again, as specified in the previous slides, the higher the temperature, the lower the dissolved oxygen, and the higher the temperature, the higher the speed of chemical reactions, and the solubility of metals and capacity or the conductivity and ORP impact as well. So it's a very good measure to have alongside with other metrics. The type of sensors you're using is a resistive type. This is important, as we will see later, because of the cable length. It is able to be used in quite a few a very standard range of temperatures. So you see that it has this what we call thermowell, which is this cap that is threaded and is protective. And all of the sensors have it mounted. With it, we can go from -200 degrees to almost 850 degrees. It is very important that it has a very slow response time. So do not expect very high response from this sensor, because it takes at least 13 seconds to achieve T90. Just to consider that is probably the easiest sensors to prepare, calibrate, and maintain. The only important thing to consider is that it has a temperature range, so don't use it in very extreme temperatures unless you use the thermowell.